circle mensuration. There's a bit of stuff that you sort of need to know. You need to know what a chord is. Okay, and that's the chord there. The arc is that one there. Segments. Okay, that's the segment inside here. And the sector is this whole thing here. Okay, the arc length. The rule for the arc length, there's two rules. One, if we're using degrees, then the length of the arc is given by pi r theta divided by 180. That's because we've got a circle, but we're only taking so much angle of it. So the theta divided by 180 is the angle, and pi r is the part of the circle. Or in radians, you can use this answer here. The chord length, again, there's that rule there, and won't go through all these rules. Area of a sector, whether it's in degrees or radians. So example 9. It says the circle shown has centre 0 and radius length 10 centimeters. The angle subtended at 0 by an arc ACB has magnitude 120 degrees. Find part A, the exact length of the chord AB. Okay, so the exact length of the chord, we've got degrees. I'm going to use the degrees. You are able to convert it to radians, that's not a problem. So length of the chord, I've got two r sine theta on 2, which equals 2 times my radius is 10 sine 120 divided by 2, so in other words 60 degrees. So I've got 20 sine of 60 is the square root of 3 on 2, so I get 10, the square root of 3 centimeters is the length of the chord. I won't write it in words. That's a part 1. Part 2 says the exact length of the arc. So we want to know this arc here. Now the arc length, and again I'm going to use the degrees one. L equals theta divided by 360 times 2 pi r. So I've got 120 divided by 360 times 2 times pi times 10. Now this simplifies. That goes once, that goes 3 times, and 2 times 10 is 20, so I've got 20 pi on 3. And this is centimeters. Again, I won't write it in words. Then part B says the exact area of the minor sector AOB. So the area of the sector is given by, again I'm going to use degrees, theta divided by 360 times pi times radius squared. So I've got 120 divided by 360 times pi times 10 squared. Again, this just simplifies down to 1/3. So 10 squared is 100, 100 pi on 3. Again, it's centimeters. Again, area of the sector, so it's centimeters squared. Again, I won't write it in words. And then part C, it says the magnitude of angle AOC. So I'm just going to come over here, change my color. There we go. Angle AOC in degrees if the minor arc AC has length 4 centimeters. So we're only concentrating on that little triangle. So if I was to redraw it, I've got that. I want to know that angle there, that's 10 centimeters, that's 4 centimeters, that's A, that's C, that's O. Okay, now first thing I'll do is here I'll put beta. And then I just want to find that. I'm just going to double it because remember I've split that in half. So I'm going to, oh no, not that one. I'll still double it anyway. So I'm going to use the rule L equals, again, pi r theta divided by 180 degrees. So I've got theta will be 180 times L divided by pi r. So I've got 180 times the length of the arc is 4 divided by pi, radius is 10, and when I work this out I get theta equal 22.92 degrees. Area of a segment. Now the area of a segment is between the chord and the arc length, so this part over here, again in degrees and in radians. Number 10. A circle with centre 0 and radius length 20 centimeters has a chord AB that is 10 centimeters from the centre of the circle. Calculate the area of the minor segment formed by this chord. So I'm going to quickly draw one. I'll draw it over here. So there's my circle. There's my centre there. Alright, I better label that O. So there we go. There's my chord A and B. I know that. There's 20 centimeters. AB is 10 centimeters from the center. So from there, that's 10 centimeters there. That is point C. I'll just label it. It should be a right angle there, of course. And I want to find minor segment. So I want to find that bit in there. Okay. So I'll first need to work out this angle here. So let me use the right angle from there. Bad right angle, but that's A, C, and 0. That's a right angle in there. That's 20, that's 10. And I've got to find this angle here, which I'll call theta. So I'll get cos theta equals 10 over 20. So theta will equal pi on 3. So that whole one is twice that. 2 times theta will give me 2 pi on 3 is the angle at the circle. So I've got that. So the area of the segment will equal 1/2 times 20 squared, 2 pi on 3 minus sine 2 pi on 3, which will give me 200. 2 pi on 3 minus the square root of 3 on 2, which will give me 200. 4 pi minus 3, the square root of 3 on 6, which means I'll get 100. 4 pi minus 3, the square root of 3, all divided by 3. That's centimeters squared.